Hey everyone, welcome back. So these videos today will be about creating a library from scratch to manage the general purpose input-output, and please use it as an example to create whatever other libraries for the other peripherals, because here we will give the example of how to set up your own memory addresses and to work from them. So we will start from the previous examples video where we are blinking an LED using an input in the microcontroller. So let me show you again. So this is our circuit, a very simple one, where we do have an input within this button, and also after that this LED will be blinking. So let me push to show you. Okay, so as soon as we have on our input, the LED started blinking. Okay, good. So the first step is to understand the memory addresses. We have been using a lot of so we have been using this include library where all the addresses are already set up. So we need to understand the addresses for this registers, and we need to understand also how to set up for the GPIO. Great. To understand where the addresses, you simply we will go to the reference manual, our best friend, and take a look to where we can find memory, and yeah, perfect. After that, so memory organization, better and good. So here we do find where we find it's obvious. So we have the RCC bus addresses, so we just need to find these addresses and go ahead with it. Good. So here we have the RCC, as this is the register we will use to enable the GPIO. And next we will need to also set up the GPIO for port A, B, and C only, because this microcontroller do have until the port C. So but later on you can add until port G. Great. So we do have now the addresses. Let's have the create the H file and set up these addresses. Okay, so you go here and we add a new file. Okay, let's call it GP drive. Yep, GP drive. Good. And let's set up the first addresses. So the first one, let's go back to the reference manual. Okay, so we need to set up this RCC. So let's take a look. So it starts with this. Let me copy it. This is where the whole RCC registers are there, but we will need to find the enable register, the APB2 enable register. Anyway, let's go for first, let's define it. Define RCC APB2 enable register. Just a reminder for the people who find this a little bit too much, please take a look to the first and second video where I explain the role of the APB2 enable register. And we need to use it as a pointer, and it's a volatile and signed long, because this is an address which is made of the 8-bit byte register. So we need to put like this. So first it's a volatile and signed. Okay, and signed. Okay. Oh, I am like this. Long. Good. And this is a pointer. So let's create it like this. Sorry. Let's make some space, and we add the address here, and let's cast it again just in case. So we put like this and two other ones. So after this one we add again a pointer and we cast again. So now we are sure we are selecting a pointer to that address. However, this is not the APP2 enable register. To get exactly the right address, let's go back to the reference manual, and we have to go to the AP, so the reset and clock control register. And if we go to this one, so there is an offset for all the registers that we taken a look for. And let's go to the APP2 register. Yeah, APP2 enable register, and we do have a offset. The address has an offset of 18, so we just add the 18 at the end. Perfect. Okay, good. So let's include here, just to check if our program is working properly. Include and the JP drive.h. Okay, JP drive.h. Good, and see if this address is working properly within our system. Okay, like this. Same. Okay, perfect. So the first step here, like when we start our testing, nothing better to use a simulator just to confirm that our program is working properly. So if I go here, I'm checking. Okay, one warning, clear. I should add an extra line here. I'll add some of them to avoid to get this message anymore. And zero warning, perfect. So let's, okay, we had a debug, and let's check how our program is working. So let's open peripherals, go to GPIO, GPIO-A, and also GPIO-C, and see if our program has worked properly. So let me run my code, and both of them have enabled clock. So the setup for the first register worked properly. Great. Same as this, we need to define also the GPIO A, B, and C addresses. So define. We need to put the first address, and then we will create the offset in the next function. So GPIO, let's GPIO A. Okay, I will put only this first line, so same, but I will change the address just to not waste time. So let me copy here, one here, and here we are. Okay, B and C. Great. So let's go back now to our reference manual. We go back to the memory map, and we do find the register addresses immediately. We take the first or the beginning of the address. So let's copy the A1. Okay. Let's copy A. Good. Let's then add the B. So you can do the same thing for also if you do have other ports, but for the moment we are not going this, just to squeeze a little bit the time of this video. And the port C. So here we do have our pointers for these addresses. Great. So now we do have these addresses quite set up, quite clear. Wonderful. So now that we have set up all this, we can start our first function. But before that, let's put some rules and or how our function will be written. Let's take the first function. Let's say we would like to initialize the pin of this a certain port. So if I call my my function void, let's say init general purpose. So my first input, I would like to have the port number, so I put port, and after that which specific pin I would like to put. Sorry, I forgot here to put, I will put an unsigned short for the pin, for the port, same unsigned sorry, misspelling, unsigned short also for the pin. And I need also to put the direction of the register. Do I want to have a register which is input or output? So same unsigned short, unsigned short for the direction. And finally, what kind of inside the sign or the inside the direction, what kind of mode I would like to use within my pin. So another unsigned short and the option. That's great. So let's take a look quickly on my register to see what are the options that I do have within my GPIO's setup. So if I go to GPIO, yeah, general purposes, and my registers, yeah, good. And this is the registers or the mode that we do have and the option for the setup. So we do have here input or output, and we need to set up all these modes. So we have the 0, 0, it's input mode, and here we have the output mode with 10 megahertz, the output mode with 2 megahertz speed, or the output of 50 megahertz speed. Okay, great. So let's define them. Even before that, let's define the numbers of the the ports. So as we need to say which port A, B, or C. Okay, so let's define the port A as 1, and we define port B. Just a moment here. Okay, PA. Okay, PB as a 2, and PC as a 3. Okay, good. So now we define that. Also, let's add the direction. No, not the direction. Let's add the exactly the direction. So let's define. Yeah, so we define the first direction is output. So we said output as sorry. The first direction should be input 0, and define. So we need to put all the type of output we need to have. So let's say out with a 10 megahertz 1, and also define the output with a 2 megahertz as 2, and also finally define the output as a 50 megahertz for 3. Okay, so now we have all the types of output, so we will not need to specify each time, so we know exactly this one, and it will help us a lot when we type quickly our code. So the pin is a number. So here in the port we have to input PA, PB, or PC, but in the So the direction we will put, is it an input or output? Finally, the options. So let's quickly take a look to the options. Let's go back to our reference manual. We have 8.1. So for the input mode, we have the analog mode, floating input, input with a push, pull up, pull down, or reserve. So we don't need to set up this one. For the output mode, we have a general purpose output push pull, general purpose output open drain, general function output push pull, and general function open drain. So we have 3 here. We don't need to set up the reserved, and we have 4 here. Okay, fantastic. Let's start them. So let's put some comment just in case. Here, list of ports. Here, the list of the directions. The list of here directions, and finally here, let's say the direction options for input. Okay, the first one. So if we define, we said we have an input as let's take quickly again a look on it. Yeah, so analog mode, floating input, or input with a pull up, pull down. Okay, so this one, input analog, will be the first one, 0. And oh, I forgot the sharp. Good. Then we define define the input as a floating one as 1, and the last one, the pull up, pull down. So define the input as pp, pull up, pull down, as 2. Great. Then let's set up for the output. Okay, good. So here let's take define. Let's go back again to the register. So we do have 2 general purpose. One is a push pull, the other one is open drain, and 2 alternative function, push pull and open drain. Okay, great. So it's an output, general purpose and push pull. Define define output, general purpose, open drain. Yeah, totally forgot to add the number here. Here will be 0. This one, yeah, I don't need to put that much. Okay, and let's do this. Here 1, and define output as alternative function. Don't worry, we will take a look in next videos about the alternative function. So this one is also pull up, pull down, and here 2. And finally, the last definition, define output for alternative function and open drain. 3. So here we defined all the parts that we will create for our function. So first we look for the port, here A, B, or C. Then the pin number is just a number we input. Unsigned short for the direction, so we will decide if it's an input or all the variants of the output. And finally, for the option for each one of them, we can input these definitions. Okay, fantastic. So now we set up our function. Let's create. Okay, so let me leave the. Okay, so we have our H, our header. Let's create the C file, so the GP drive, general purpose drive. main. Fantastic. Let me bring it. I don't need this one anymore. So let me bring this library here to the GP drive. Okay, so now we will start working on finally on this function and put it alive. Great. So let's create it. Okay, so the strategy to start initializing this function is we need, so we do have here the GP A, B or C, so we need to make a selection for each time. If it's the port E, we have to activate the port E in the APP2 or B or C, so we have a conditional if. And also for the activation, as you taken a look, just let me bring back, let's go here. So to initialize, we have the control register low and high. So we need to set up if we are in the low or high register. Okay, so we need to have a small condition saying that we are offsetting by 00 or we are offsetting by 04. Okay, so that's, I think, the only step which is a little bit tricky here. Good. So we'll need, let's start making the first variable we will be using. So we have to need a volatile unsigned long, which is a CR. I forgot the star. CR, this is the register we will be updating. Then we have unsigned short, the T pin, or we can just skip it, but just for the understanding purposes. So this is the pin we will be using here. Okay, and the unsigned short the offset. Have a clean code at least. Unsigned short offset. So the offset is used to create the to define if we are at the CR low or CR high, and we initially put it as 0x00. Okay, good. So we set up the variable, the internal variable, so we can manage. So as I said, so let's go back again. So let me show it again just in case. If we do have, so the pin, let's start from the low. If my pin is from 0 to 7, I'll be using the control low. And if my pin is going from 8 to 15, I'll be using the control high. So let's go back here and make a small condition. So if my pin is greater than 7, from 0 to 7, then like this. So at that time, so the T pin, or the pin that we will work with, will be the actual pin minus 8, if it's greater than 7, and my offset. So here, so if my offset is 00, I mean I'll be using the low register. But if that's greater than 7, I need to use the high register, and I'm putting 0x01. Okay, here I owe you one explanation. So if you take a look on this one, so it says my offset is 04, but when I be adding the +1, this is not because for this 04, but I'm moving to the next memory. And let me show you where is it. So the register table, there is a register table, just a moment. Where is it? Just let me go here. Yeah, not this one. Sorry, take a bit of time, but it was the explanation. Okay, register. Okay, this is not the register I'm looking for. Yeah, this is the, so you know, this is also not actually the register table I'm looking for. Analog. Pardon me. Where is this table? Yeah, okay. Good. Alternative function. So sorry, this is taking a bit of time, but it's very important to understand the register. Yeah, this is. So now I'm adding +1 because in the memory itself, even this one is in memory 04, I'm adding one step to the memory, and that's why I'm going offset 1. And it will be the same logic for the input or the output register. I'm adding another step, so we have so my offset will be here 00 for the low, 01 for the high, 02 for the input, and 03 for the output. It will make sense when we will make more the practice. Okay, good. So now we put it our offset. So let's start the condition. So if my port, let's go back here. If my port equal to 1, so it means I'm using the port A. Let's take this. Okay, just move it here to make clean code. Okay, so the first thing, the RCC APP2 enable, we will need to make this, so same as the previous code, so we can even bring it from here. So I'm enabling port A, bring here, okay, so this is what we need to do. And the next one is to set up the CR register, the new CR register, which will be also, we need to cast again. It's a volatile unsigned long, and it's also a pointer. We never forget that's a pointer, and we will use the address of the GPIO A, great, plus the offset. So we just need to go to the next register. So by putting this, my address will automatically be the +1, but here it's a 0, so because here it's 0 or 01. Okay, good. So what we have done here, we set up the CR register to be located exactly where we want for the setup or the control. And then what we need to do is just putting the same code here and adding the else if it's equal to 2. So we have here the C is 10. So let's quickly go back to our GPIO code, our reference manual, go for the APP2 enable register, and the B register is number 3, so it will be 8. So here 8, and here GPIO B. And finally we can add 3 here, the final one. I think we already have the C, so it's 1 0. Not here, so 1 0, and we put C. Wonderful, wonderful. This is wonderful. So we almost finished the init. So what we can go now for is to set up our control register. So the first thing to do is when we would like to set up the register. So we already here created and addressed the register. So now we need to change this register value. So what we make now is to update it. So and I usually go through my steps. I need to put it here the 0 first, or to clean the bit. So I have a clean area. So just to show you in the reference manual. So let's go to the register itself, the control register. The initial value for each bit is 4, and I just like to clean the both one, the configuration and the mode, so when I can input, there doesn't have any issue within my my new setup. So always take it as a good option to clean first, put it as a 0, and input your selection or mode and configuration. So to clean this code, so let's go to here. I need to put yes, and equal. So as usual, putting this one to put a 0f, 0xf, but that we need also a 0xf, and we move that one by the T-pin direction. T-pin here, and multiply by 4, because don't forget this is 4 pins that we have to move at each base. Close. And so now this is what to say, we reset the target pin. Okay, so after that we need to set up for both. So we do have, first we have to set up the mode and the direction, or the direction first, sorry, direction and the mode. So quite very easy, and equal. So we have to use, pardon me, direction, so the direction pin that we selected, and we put the T-pin, and we multiply by 4. So this is to put in which direction, which, so to set up. So we are moving here, I am moving my the setup of the pin to the direction I need. Okay, I multiply by 4, and here, so I set up my direction, but I still need to put the option I need. And then, so what I need to make is to create the option. So to make the option is to just add the option that we set up previously, so PT, but we have to move it to the right pin we wanted to put, and this is the T pin coming here, and we just multiply by 4. We move it by 4, 1, but we add 2. Okay, just closing, and great. So this is closed. So here, so I will add here, set up the direction and the option of the pin. Great, so now we do have the init function ready. Okay, so let's go back to our here system and to our main program and update it. So we normally we will not need this anymore, and what we will need, so let me put it as a comment. Good. So now when we put it as a comment, we can try to make our input function, so the init function here, so init gp, and then we would like to set up which port, so PA, so and then which pin, so for port A we set up the pin 0, and so the mode as an input, and also the direction as an input for we said that we needed an input as, just let me confirm again with the this one, so it's an input as yeah, with a pull-up pp. So let's get it, so pp, and we should be fine. Okay, we do have an error expected. Okay, some setup looks to be wrong. Take here. Okay, I added this one here, so we should never add for the definition. Okay, delete and delete. Let's save. Okay, fixed. And init GP again, so we use the PC now, and we would like to set up on the pin 13 output, and let's put output as a 50 megahertz, the fastest one, because we can do it. And it's an output, a general purpose pull up, pull down. Okay, so seems no error at all. That's great. Let's try to run, check. Okay, 3 warning. Okay, so this one short direction, the new line, yeah. So let's add this new line here and delete all this. So okay, 2 warning. So we do have a fill without a new line. Okay, so H2, we need to add this one here. Control S. Okay, let's check. So 0 warning. That's great. So we do have a clean program. As usual, I'm still working on the simulator mode just to see if my setup is working well or not. Okay, so let's open the peripheral tools and go for GPIO-A and GPIO-C to see if my setup went well. So let's run my program, clock enable, and I do have an input with pull up, pull down for the port A. If we go to the port C, we have a GP output push pull. Great, this is exactly what we wanted to do, and we have been doing it without any library at the moment. So we saved all this code here. We saved all this code in 2 lines, and we can set up much easier all the other pin. So now what we have to work on is the direction and the setup of the pin. So how to read if it's 1 or a 0 for a certain pin. So that's a good timing to start creating the input function and to read directly the pin. Good. So let's to define this function, so we need, as an output, we need a int. Even less than that would be fine. And so this one will be a read GP. So as the first input we need to put is so we need to specify which port. So in unsigned, even unsigned short would be good, so we don't need to waste so much memory. And the port, also the unsigned unsigned short, the pin, so which pin we need to set up. So that's all that we need here. So we need to specify the port and the pin to read the status of the register. Let's go here and start our new function. Great. I think this one will not be that difficult. So the first, let's first, as usual, set up our the register that we will be reading. So volatile unsigned long. Okay, so we will call it the so we will be reading, so as you can see here, we are reading from the IDR register, so we'll call it same. So the IDR, that will be the register we will need to set up, and also the offset. So we put the int or even unsigned long, just unsigned long offset, because we need to specify the register itself. So the offset will be 0x02. And so as we set up the offset, I forgot the equal sign. Good. And finally, so this is what we need to return is our state state variable, which will return 1 or 0, depends on the state we do have. Good, so this is done, so we can now start our code. So as usual, if the port, small characters, port is equal to 1, so here we need to set up the IDR register. Okay, so the IDR will be equal, so it will be exactly almost same like here. So without, yeah, here, so IDR will be equal to the offset, which is 2, and we do add the else. We don't need to set up any more else, so we don't need to set up any more the APP2, and we add this one, so just to save time. So if it's equal to, so here if is A, here is B, and same as for the last one is the else if. So let's bring it a little bit back here. So if it's 3, which is port 3, 3 which is port C, so we put the port GPIO C. So now we have set up for each case if we wanted to read the port A, B or C. So after we set up the IDR, the next step is just to read the state. So the state is read, so from the IDR register, we go here. So we need to get the address of IDR, and of course we have to take the pin number. So here we put the pin number. So here when we do end, we will clean all the other one, we will remove all the other one, we are masking them, and we get only the pin direction. Okay, so after that we close it. So after doing this, we go back to the direction of the pin, we move it back so we have 1 or 0, and our code is closed. Just a moment. Perfect. Okay, so sounds good. Let's add a new line here to avoid any warning. Okay, let's check. 2 warning. Okay. Ah, yeah, true. We never return the state, so the last step is return state. Good. So by doing so, hopefully, yeah, we cleaned all our systems. So if we go back here and we would like to change this one, so instead of putting if GPIO of the IR register is equal to 1, here we just put, instead of this one, is read JP. Good. So we said the port A and pin 0. So if we do this one equal to 1, then so we can blink, and else we will be just shutting down the LED. Let's check if, okay, 0 warning, 0. So this is the moment of truth. So let's open, so let's check before that if I put it. So let's go here. So we will be debugging directly in the microcontroller. We go to setting. Yeah, we have reset and run directly. Perfect. So we are ready to upload. Let's open the webcam and check. So as of now we have a blinking LED. So let's check by doing this. Okay, so I'm uploading. Let's do like this and uploading my code. Good. Oh, great. So we can see that this code is working perfectly. Yeah, even I loaded again. So we do have now a code working and the LED is blinking. So the reading function is working quite fine. Wonderful. So The next step and the final, almost the final one, is to change this, to create this toggling. But before the toggling, we have to make a write function. Good. So let's start the write function. It should not be that hard one, same as a reading. So let's go here. Now first do 8. So how to create a write function. So the input for the write function, so it's a void. We don't need to get anything from it. And write GP. As usual, so we will use all same for this one. We need to specify the port and the pin and the status. So unsigned short status. Okay, great. Okay, so we do have two status. It's a high or low. So let's define the status here. Status definition. So we to have always a clear definition of my writing. So let's define low as a 0 and define high as 1. Okay, so let's put them both at the same level. Good. And so we will specify the port, the pin, and then if we wanted the pin low or high. Great. Let's go to the function and go to the here for the C file and start creating this function. Okay, so we will be using exactly the same code as the read. So I will just copy here, so without the return and without the state, because it's a different strategy, a little bit different strategy. So here, so I'm removing this one. Actually, it's not status but state, what I need to put here, and I will change it also in this one. Okay, and state definition. Okay, so let me save this just to keep things logical. And here I'm going the ODR, and if we can back to the reference manual here, so the ODR register, where is the ODR register map? Yeah, so the ODR is the the fourth register, so +03. Now I guess now you get used to this, and here we'll call it ODR, ODR, and ODR. Great. So all this one has been set up. Now we just need to put the status of the ODR. So I'm be writing a very condensed picture of the ODR. So here I put state. So state. So if the state is I wanted state 0, I will go to the ODR, and I will, so if the status, sorry, well, let's start. If it's 1, the status should be equal or equal, and state to the pin, the place, the direction of which pin, the pin number. Okay, so now we set up if the state is 1. So let's put it between two brackets just to have a clean code. So we will go to the, so ODR will get 1 to the position of the pin we set up. Or, so if it's the else 1, so if it's 0, the ODR will get we have to put it as 0, so it's the opposite, and equal, and 1 goes to the pin location here. So yeah, I forgot to add the brackets here, and like this. So now if my state is 1, So I will put 1 in the ODR register at the location of the pin. If my pin is 0, oh yeah, I forgot here, I need to reverse it. Yeah, so I will put a 0 at the location of the pin. Great, so I have here my space, and I do have here my space. Great, so now we created the write function, but after that, so what we need to finish is to make a toggle one. Okay, so we have the read and the write, so let's create a toggle one. The toggle is much easier, so we almost need only the port and the pin, so void, and we call it let's say toggle GP. Even toggle will be fine. So as usual, we need to put the port and the pin, because the toggle we need to specify which pin. So actually some initialization should be done, but this is within the understanding of the developer himself. Okay, let's go now to the C file and add the toggle function. I guess now you immediately can imagine will be the code. So if my reading register of a GP of the port and the pin here, so if it's equal to 1, so we don't even need to put equal 1 as it becomes that obvious. So we will write on the GP the pin and sorry, the port here, port and pin. Okay, so we need to write, if it's equal 1, we will put it 0, else, let's go here, and we add it as, just a moment, like this. Okay, so we'll write it as a 1, and we do have our function of toggling. Okay, let's save, see if everything is correct. Yeah, 0 error, 0 warning. So now we will go back to our main function. So for the toggling here, we will change it to toggle. Yeah, we would like to toggle the PC, the port C, the pin 13. Here. Else, we would like to write on the JP as user PC and 13, and it will be a 0. Okay, great. So we can say now our function is ready. Let's check. 0 error, 0 warning. Let's see if our code is working. Okay, and let's push, and that's blinking. Great. So we do have now a very compacted code that will help us to quickly make our design from GPIO perspective. And even also this code will, so with this init function, we will be easily setting up the alternative functions for the next modules, which is about the, for example, the UART or the SPI. So that's quite a great code to quickly, easily set up the next part. Thanks a lot. Stay tuned for the next video. We will be discussing about how to use the interrupt and to get our microcontroller more efficient. Thank you. Talk to you soon. Bye.